Look at any population of a single species. Despite sharing the exact same genetic blueprint, the absolute rule of their existence is variation. No two organisms are exactly alike. This variation functioned as a foundational axiom of biology in the 19th century, long before the emergence of modern psychology. Charles Darwin observed that across the natural world, even within the same immediate family, perfect replication does not exist. His cousin, the polymath Sir Francis Galton, took this biological observation and mapped it directly onto human behavior, studying our intelligence, physical capabilities, and social traits. Galton cataloged an immense variety of human characteristics. He recorded visible physical metrics like height and hair color, alongside complex internal traits like physical endurance and cognitive processing speed. But observing that people are different is the easy part. The challenge for a behavioral scientist is figuring out how to rigorously measure and categorize an abstract concept like uniqueness. Psychology cannot rely on qualitative descriptions or subjective feelings to do this. Evaluating human traits requires a strict mathematical framework. Individual differences are not treated as random quirks. They are highly specific, quantifiable data points that deviate from an established norm. To measure an individual's unique traits, you must first mathematically establish what is normal for their specific group. This is a standard normal distribution curve. The baseline reference point for any measurable characteristic is the average, or the mean, sitting right at the center. Consider a hypothetical classroom where a cohort of 30 students takes the same standardized test. Averaging their results establishes the group baseline, let's say 50. Individual students map against this. Some land near the middle, registering 39 or 35. Others present a major anomaly, landing far removed at 91. Measuring these gaps requires the concept of variance, or deviation, known in Hindi as Vichlanshilta. Deviation is strictly defined as the mathematical distance from the mean. The further the score from 50, the higher the variance. In psychological terms, your individuality is literally defined by how far you sit from the center of the crowd. What exact aspects of humanity can actually be plotted on these curves? Psychologists like B.F. Skinner and Leona Tyler defined strict parameters. If a trait cannot be measured, it cannot be evaluated for individual differences. This includes highly visible physical metrics, like physical size, total weight, reaction time, and eye or hair color. It also includes internal mental measurements, such as intelligence quotients, academic achievement, and specialized cognitive aptitudes. But a human being is not judged by a single test score. We are hundreds of overlapping traits acting simultaneously. This introduces independent trait variance. Scoring highly in one category doesn't guarantee another. Look at the cognitive axis. Someone might score perfectly average on intelligence, yet that exact same person might present as an extreme outlier in emotional volatility. Fine motor skills like walking, or specific interests like an affinity for science over music, operate on entirely separate developmental curves. Every person functions as a unique constellation of average and extreme traits, plotted across dozens of independent domains. So what underlying forces push these trait data points away from the centerline? The first driver is heredity. Biological parents pass down genetic baselines that establish a starting point for physical characteristics and fundamental temperaments. The second driver is the environment. The social and cultural ecosystem a person grows up in dictates their morality, ideals, and daily behavioral habits. Peer groups and local customs literally shape the psychological expectations of what is considered normal in the first place. The third driver is age and biological maturation. The trait matrix is not static. As a child ages into adulthood, cognitive abilities sharpen and emotional responses evolve. It is common for adults to look back and laugh at their own childhood behaviors. This proves that internal baselines shift as time passes. Heredity, environment, and age constantly interact to build an individual's baseline behavioral capacity, but they do not dictate every single action. There is a final, highly chaotic variable in psychometrics, the immediate present. Baseline psychological traits do not operate in a vacuum. They must constantly react to whatever is happening in the room. This is a behavioral override mechanism known as situationism, or stitivad. Consider a practical behavioral paradox. An employee who possesses an inherently irritable, aggressive baseline trait matrix. When interacting with a senior manager, their emotional profile shifts. In the presence of authority, the immediate context suppresses their natural irritability, resulting in polite behavior. Yet, if that same employee interacts with a subordinate seconds later, their aggression returns to its baseline. The employee's underlying genetics and baseline traits did not change in those 10 seconds. Only the situational parameters did. The immediate environment acts as an active, real-time filter, temporarily suppressing or even amplifying our baseline psychological traits. When you layer these variables together, the mathematics begin to accurately map the human experience. Our biology provides the raw materials, our environment sets the long-term baseline, and the situation triggers final behavior. Because there are dozens of independent axes, the sheer mathematical probability of any two individuals sharing the exact same deviations is virtually zero. Human uniqueness emerges from the precise, unrepeatable intersection of mathematical variance and momentary context.